Okay, so thanks for inviting me to present AMBIT. I'm sure that most of you are familiar with, at least have heard about. So I would start with a reminder that AMBIT is not a database, single database. This is basically a set of tools, open source tools, which allow us to integrate very different sets of chemical substance data. It has started as a Cefic LRI project in 2005. We are actually currently also having an extension of that, but also it was continuously developed and extended through quite a large number of Commission FP7 and Horizon 2020 projects. I think there are more than 10 up to this moment. Because it's open source, we can accumulate this functionality across all these projects without having the hurdle of IP protection and which projects contributes what. So this is really is contributing for accumulating functionalities across different communities. What we have, of course, this is a standard search for chemical structures, but also what is quite unique until this moment as well is this is chemical substance, not only chemical structure database. And of course, the read across workflow, which was designed in very close collaboration with Clariant, especially for AMBIT LRI project, which I'll be demonstrating in details. Of course, from the beginning, we are including variety of prediction tools. In fact, in this publication, which is highlighted at the bottom, this is from 2011, we then had REST services with machine learning and this was basically a distributed system using application programming interface, harmonized one across all the partners of OpenTalks project, which was, I would say, at this moment, this was quite ahead of its time 10 years ago. Now everybody is doing machine learning over the web. So let's go into a bit specific. This is the site where you could find details about AMBIT software and download the software, different distribution, also source code. And of course, we have started as a chemical structure database at the beginning. We're still using AMBIT for chemical structure database. For example, this publication from 2017 from Horizon 2020 Escape project has a large amount of SAR points, 1 million compounds curated from PubChem and Campbell. There are now many similar databases for the last years, but this is one of the first. But what we are currently most busy with is not chemical structure database, because the real chemical substances are they usually consist of more than a single structure, and this is a definite challenge when we want to represent substances in real industry conditions, nanomaterials, advanced materials. Even now we've been involved in a new project for microplastics. This is a single structure is not sufficient. This should have been very clear from the UPAC, and rich definition of chemical substances, especially rich definition is since quite a while, and it classifies substances into monoconstituent, multi-constituents, UVCB, and several other types. This is what you encounter if you really want to record data about substances as they come from industry who makes them. This was something we have been basically taught in 2012 in LRA project, and we updated the AMBIT data model to handle substance composition. Then when you have a property which is calculated for a single chemical structure, this is assigned for components of the substance, but measured data, all the experimental data is assigned for the chemical substance. We have published this a couple of years ago in a chapter in this book, Big Data in Predictive Toxicology. This is the schematic of how the data model looks like. So you could represent any substance of material with a composition and constituent. The constituent has a role, what it is, what's its function, and ratio, and it could also be, they could also be related, different constituents. So how it looks like in software, here is on the left is a representation of formaldehyde from rich dossiers. You see this is definitely not a single formaldehyde structure. There is a lot of additives and other impurities and other structures in there. And on the right, you could see gold nanoparticle with core and coating. This is a very, very simple example with single core and single coating. These days, with advanced materials, things are a lot more complex, but this is the idea. So we have been working with nanomaterials database for since well, 2015 or so, and I'm happy to say that we have accumulated the largest EU database from EU-funded project in this nanosafety data interface at searchdata.nanomapper.net. You could go there. There's not everything is open. Most of the databases so far projects access is restricted to project-based only, but they are coming public one by one. For example, this publication towards the fair nanosafety data will be out in a couple of weeks, and NanoReg2 project data is becoming public along with this publication. So please consider this is this was quite a big effort, and it's continuing with new projects and ongoing projects. We are accumulating nanomaterials data. Parts of the nanomaterials data from the earlier NanoReg1 project is also available from European Observatory of Nanomaterials. This is also using AMBIT's API on behind with services hosted at our place, and also the our open source client JavaScript library, which is used to render this page. Of course, they have accommodated it with EU-on style. So to finalize the work with nanomaterials, this is all based on AMBIT. This is basically exactly the same software, but just the data within it is nanomaterials, and all the data model and the data structure are exactly the same. And there is no surprise, because you could find even on EU-on page that nanomaterials are chemical substances, so there is no reason to have a separate database for substances and nanomaterials. They are the same thing. The 3 publications right now, which I'm citing here. There are a bit more, but this, I would say, these are representative, especially the latest one that on the bottom right, which is from last year. This is, we report how we have a flexible tool for import data from user-friendly Excel templates, which are aligned with data providers, and we have a flexible software developed by colleague Nick Korchev, who is on the call, to import this data. Now coming to the read across tool developed by for LRA projects. I'm sure you have seen this screen because this has been online for a while, and there have been a couple of workshops and video lectures. I'll go for those who are new. I'll go to some details on the read across workflow. The functionalities here are starting from the standard chemical structures and integration of predicting tools, but also a very specific read across workflow, which will be in the next slides. So one caveat with searching for structure in AMBIT is because we have structures, one and the same structure could be constituent in many substances. When you find the structure, it's not the end. You have to go deeper into details and see which substances contain this structure as part of it. So what you see on the step 2 is once you find a structure, be it exact structure, similarity, or substructure, or any of these standard way of searching, then you have to dive down to see which substances are related, and then the data is assigned for the substances. You could go for substances and explore the data. We have developed a flexible mechanism of showing different types of data. This is open source JavaScript library, JTools. You could find it on GitHub. And this is configurable. We have been using it for many years for displaying very different types of data. What is shown on the screen is the FISCAM tab of a particular substance. Now going into the workflow for read across category formation, these 5 steps, main 5 steps which are on the rows, have been 5 steps on the columns: assessment, identify, collect structure endpoints, assessment details, and report. These have been designed by Clarion computational toxicology team, and for the purpose of having user interface to help them organizing data from Euclid system they have gathered, and develop and work with many substances for read across for many substances, and of course then generating reports for submission. Now we have implemented this as a web user interface. If you go to the ambit.lri.ideaconsole.net, then you have to log in. This is free registration. Anybody could register. If you don't have user, you could do it now or later after the talk. And in the menu assessment, you could start a new assessment. Assessment is a placeholder for what for the read across or category task you are going to be involved with. You could start with an empty template, but also you could use some existing assessment as a template, and it will copy part of the information, but of course not everything. So it's kind of just as a template. You have to enter a set of fields to help with metadata of this assessment, like who is, what this is about, and also very important is who has read and write access, because you could develop this by yourself and only use it alone, but you could also share with colleagues or even outside of your organization with users who have been registered in AMBIT, and grant them read access or even write access if these are colleagues who you want to help with the read across assessment. So after this metadata field, the first important step is, of course, to find the structures. With this now legacy version, basically, we have all the standard structure search, exact structures, similarities, substructures, and this is not once and done process. You could perform certain search tag with on the left column with the selected structure with available tag, either it's target or source or category member. And you could do this many times, just switching similarity, search, exact structure or substructure as many times as you like. The structures will be accumulated and you could see them in the list collected tab. Something not to be forgotten, there is a field to import, to enter the rationale, the reason why you are selecting this structure for the read across. Because nothing here in this read across workflow is completely automatic, and this is on purpose. Because you can do similarity search and find many similar structures, but it's not necessary that you want all of them in your read across assessment. So they should be expert-based reason entered for each of these entries why you want this structure included. And of course, these structures are accumulated. You could see them in the list collected as these slides is showing, and all the rational column is filled in. Now the next setup is to select which endpoints you would like to include in your read across assessment. And here comes again the logic that the data and the endpoints, they are not assigned to the structures, they are assigned to the chemical substances. So it's very important to click on this folder sign icon and explore which substances are related to this structure and how. And in the column on the right, it says that this the structure on the screen is contained in the first substance as constituent, and in the second substance as constituent. If you scroll down, you might find impurities, etc. So what is important is to check the substance here, the substance you would like to use for your read across assessment. Next slide shows which endpoints are selected. They are automatically selected when you check the substances, and the checkboxes are based on where there is data for particular endpoints for the selected substances. You might wish to select all of them, regardless whether there is a data or in the database, there will be a way to enter new data in the matrix. Then the next step with assessment details, it shows automatically generates the working matrix, the initial matrix for read across. You see maybe something a little bit different than you could find in other read across systems. You have the substance, and you might have then several structures for each substance. Everything else is more or less the same as you could find in other read across workflows, and we'll go for the working matrix. So the initial matrix is dynamic. You could go back to the structure collection and endpoint selection, change it, change the information there, and then the initial matrix will be automatically updated. Once you go to the working matrix, there is a button. The first time you go to the working matrix tab, there is a button to create the working matrix. Once this is created, it actually makes a copy of the initial matrix, and this cannot be changed. The structure of the working matrix cannot be changed for this assessment. You could eventually use this template as for new assessment, and then it will be without working matrix. You could change the matrix structure and go on. But once you create a working matrix, the reasoning is that you are happy with the structures, substances, and endpoints, and you'll be only working to completing the matrix itself. So the matrix is editable. First, you could explore details on each the entries there. All the links are clickable. And you could click on the link and show details, or even you could go to AMBIT system itself and explore all of the details about the particular substance studies. But also the matrix is editable. You could click on this plus signs. It's probably not seen quite well, but these black dots are plus signs. When you click on them, depending on the cells you are, there'll be a window with allowing you to enter particular data points. And the data point is, of course, related to the column where it's being edited. This example is for short-term toxicity to fish. Most importantly, you have to enter justification why you are entering new data which is not already found in the database. You'll not be able to finish this, to close this task if you're not entering justification. Once it's entered, it's being highlighted. You have to save it. Now the new version, actually, it's automatically saved. And also you could actually also delete entries from the matrix. It's not shown here, but this is also possible, and also you have to enter reason why you decided to delete some piece of data. Now, what is included in the working matrix is not only experimental data, depending on the endpoint selection and available models in the system. The working matrix will consist also of predicted values. Here, the example shows tox3. Of course, with any integrated models like VEGA could be shown on the system. So there is another way to run the predictions, like the user interface, which is, I believe some of you should be familiar with tox3 Online. We had also integrated previous VEGA models developed by Mario Negri and others on the call, and now have a plan to integrate the latest VEGA in the recent version. At the end, the whole read across process, when it's considered finalized, it could be marketed as such, and it is possible to download, generate several different reports. One of the reports is the working matrix itself. It's an Excel file with certain structure. It should be pretty familiar. Also, actually, I like better this layout where the structures and substances on the rows and endpoints on the columns. Other assessment reports, this is HTML on the web page, and this is very comprehensive. It will show all of the action you have done, which substances have been selected, which structures, why you have edited the working matrix, which lists justification, etc. And this also could create Word files. You can create and download Word files out of it. So this is basically the same information you have in the user interface, but represented in a different way, which could be printed and submitted. Now, what I was showing is basically the legacy AMBIT tool, which have been online for a while. We're now working on the next AMBIT 3 version. What I'm showing here is some statistics, charts of the data in AMBIT 2. So this was data which was provided by EGA almost 5 years ago, and now the new AMBIT 3 is it contains the data which is regularly updated by EGA. Right now, the statistics shown for REACH study dossiers, which were released in August last year, and there are a couple of more recent releases which are going to be in. What I would like to say that apart from changing updating the user interface, we have of course exactly the same read across workflow, a little bit re-implemented, but it looks like the same. We'll have all the search structures, similarity, and substructure as before, but we'll have also more search types. And we have also free text search and faceted search and dashboards. So what you see as charts here, they are automatically generated and present on the website of AMBIT 3. So they could be explored to give you an idea what's new in the system and what's in the system. Of course, we have all the same read across workflow, which I'm showing a screenshot here. So here the message is, if you like to become beta tester for the new interface, send me a message or send a message to this email. We'll be happy to involve you and help you. If you like to help improving the system, please send us a message. Now, I think a couple of charts might be interesting for you. This is especially in the context of data reliability. What you see on this chart on the x-axis, this is the year of the experiment. You could see that there are some not really reasonable years like 0,083 or 9999. This is definitely not something right, but this is what comes from the EGA files. And the color coding should be obvious. This cleavage scores, reliable without restriction, reliable to restriction, not reliable, not assignable, and blanks and undefines. So we're looking, if you're looking for reliable without restriction, this is the green color, and you could see for FISCAM, which is on this screen, this is less than a third of each type of the assays. This is the chart, bar chart on the bottom. On the x-axis, this is different endpoints like boiling point, dissociation constant, melting point, etc. So more or less about third or less of the third of the data is cleavage score 1. We have similar charts for we have similar chart for tox and ecotox environmental effects. Here, this is a different, the same color coding. Rich dossiers from 5 years ago on the left, and rich dossiers from 2020 on the right. You could see that for tox and ecotox, the green color is also about the third. For ecotox, it's even less. But the amount of data have been increased at least twice, roughly, on each endpoint, which is a good thing. I'm aware that this group has had some trouble with skin sensitization, so this is some charts from REACH dossiers 2020 for skin sensitization. This is the same color coding for cleavage scores, but only for skin sensitization. And what you see on the blue bar chart is the different guidelines or SOPs or whatever you could find in the place of where the SOP should be. You could find all the OECD guidelines for skin sensitization, but also many free text entries. Like the first one starting, they know official guideline, we're doing this and that, and this is what you find in the REACH dossiers. This is not only the status for skin sensitization, but also for everything. I have to say that compared to 5 years ago, this is a bit more cleaned, but it still has a lot of work to be done to be a reasonable data curation applied. Demonstrating the new facilities for faceted search with the example for skin sensitization. You probably could see here on the hits list there is several filters. We are looking for cleavage score 1, skin sensitization, and only data where we're looking for EC3 only. And then we have about 550 hits substances, which we could go exploring one by one by clicking on the link below the name. But also we have an export tab where we can export all the results into a tabular format. So basically what I would like to highlight here is you can export the results yourselves. It's not necessary that you ask, for example, me or somebody else to export the results you want to work with. Another way for free text searching demonstrated with my favorite query, caffeine. Of course, when you just search for free text, the system search for everything, not only the names of the substances. This is intentional, and you could find interesting things why gallic acid is found for caffeine, because they have been in some study both, and this is how it's written in the guideline. Of course, we have all of the search facilities like before with structure search and exact structure similarity, etc., which is shown here. One more facility which we have introduced to help people with predefined queries. We could define queries for some subset of criteria we find interesting or we have been told to do, and then if you just click apply, it goes. The query is generated the same way as you would do this by clicking the facets on the left. And if you like to ask to add more queries, then please suggest which ones. This is just an example. We could have tens of them or even 100. Now, how this all works and how this could be accessed, it could be accessed not only through the web pages I was showing. As I said, AMBIT has REST API already 10 years. And besides the Java client we had from the beginning, now we have JavaScript clients which we're using for the web interface. There is also Python client and a very initial NIME client for querying AMBIT database. If you like to install the AMBIT Docker distribution, you could go to our GitHub repository for AMBIT Docker, and it should be easier than our previous system of installation, where you could download the var file, run Tomcat, run MySQL, etc. We also support MariaDB. Now everything, all of this is integrated in the Docker. Here, what is distributed with is the nanoreg data, nanomaterials data from the nanoreg project. We cannot distribute rich dossiers this way, so this will be there will be a download for rich dossiers within Cefic download for Cefic members, but it will be the same Docker where you could plug in the rich dossiers files. And of course, we are planning to include more than rich dossiers. Current plan is open food talks data, repdos, which are already integrated in the development version, and several other in consideration. So this is all from my side. I think it's good we have 15 minutes for discussion. So your question, please.